Hi, I'm Sammy Miles, Editor-in-Chief with AMP Media. I'm here today at the AMP Annual Conference and Expo with Bartek Dajnowski with GC Laser Systems. Now, I've got to ask you, what does the GC stand for in your name?
I love that question because whenever someone sees our product for the first time, we always wait for that moment when they say, wow, this is a game changer. And that's what the GC stands for. It is a game changer. And the first prototype that I made in 2014, when we saw how well it performed, we immediately all said, this is a game changer. So the name stuck.
Wonderful. And can you tell me a little bit more about GC Laser Systems?
Absolutely. So first and foremost, we're an American laser equipment manufacturer. So we design and make everything in the US. We are a laser equipment manufacturer first, but full integrator second. So we offer handheld solutions, but also full automated robotic systems, crawlers, laser enclosed cells. So you can put parts in that get cleaned, servicing various industries. And the company is a woman-owned business. The technology is the result of my personal 25 years of laser cleaning experience. I've been doing it for a very long time. And the first prototype was a result of 15 years of frustration with what other techniques and other technologies cannot do, and other laser technologies cannot do. And then the products themselves are built to withstand very durable environments, to be used outdoors, to be used in environments that have moisture, high humidity, cold environments. So it's been a technology that's been evolving for a very long time. And we have a family of, close to 20 patents, somewhere around there right now. So this technology is patented worldwide, and it is designed to be used worldwide. So these machines can be used on any power supply globally, 50, 60 hertz, and it's been driven by necessity. So the first industry, for example, that our technology was used in was the architecture and fine art conservation world. So cleaning monuments, priceless artifacts, things in the Smithsonian collection. 3,500-year-old Egyptian obelisk was actually the first thing that the laser ever cleaned, which was kind of symbolic and cool because it's the obelisk in Central Park behind the Metropolitan Museum. It's a symbol of light, and it was restored by light. The U.S. Supreme Court facade, the capital of Louisiana, Sydney Harbour Bridge in Australia, Notre Dame in Paris, churches, all kinds of monuments and artifacts and ancient artifacts have all been cleaned and safely restored with these lasers. But also things like the printing industry, printing presses, nuclear decontamination in power plants, radioactive abatement, lead abatement, corrosion removal. The Air Force, for example, is one of our customers. So is the Navy, the Army, the Coast Guard. So it started off in cultural heritage, and we like to say it started off to be safe enough for art, and it's definitely safe enough for industry, and offers unmatched precision in what we do.
Wonderful. And what makes your laser technology unique?
So several things. We like to push the limits of physics, and if people say it can't be done, we're usually the first ones to do it. We were, for example, one of the first to prove that you can produce a texture on metal with a laser. Also, some people said, you can't go more than 100 feet with an umbilical. We went 300 feet. The technology can be dialed in, for example, to target only corrosion, like surface rust. It can be targeted to remove a coating, or to remove chlorides, salts, to remove contaminants, hydrocarbons, and it's all very precisely controlled because the parameters of the laser are dialable by their pulse duration, their pulse frequency, pulse energy, scan speed. And what we're doing sounds very complicated, but it's really simple. At a simple level, we're just exciting the molecules of what we're targeting, like let's say rust. And they get so excited by the energy they absorb, they literally shake themselves apart and eject off the surface or ablate. So we put easy buttons in all of our machines too, so there are presets. So after we've trained people on how to use it, they could just have presets that they choose for their particular application.
So how does the circle work?
So we design and make our own scanners in several different ways. And the circular scan, again, has no hotspots. It's a very fast scan, rotating quickly. And it's actually able to wrap around and conform to shapes. So there's things that we've patented, and there's also things that are kind of our secret sauce and our proprietary optical solutions. So the beam is actually rotating, again, very quickly. So it's not stopping anywhere. So it can quickly process the surface and not have any heat-affected zones like you might have with a line scan, again, which has to stop and change direction very often with a galvo mirror. But another key thing is also that beam is coming out as a cone. And that's incredibly helpful for cleaning complex shapes, corners, wedges, rivets, frame parts, because when the leading edge hits a surface, it hits it at one angle. Trailing edge then catches it at the opposite angle, and that helps it wrap around a shape. So if you see one of our lasers going over a complex shape, you'll see it'll actually wrap around things as it goes over it and conforms to it. Another great thing about the process is that light does not apply any pressure. So the operator doesn't have sand flying back in their face. They don't have media. So they can go into a tight corner and laser clean it, and it's actually relatively comfortable. So we like to say if you can shine a flashlight at it, you can shine a laser at it, and you can clean it. So it's a line of sight process. But this circular scan is incredibly efficient at wrapping around shapes. We also have another feature that we call auto scrub, where we take that circle, also patented, and now it's rotating in a circle, and as it goes over a surface, it'll interact with it maybe a couple hundred times per motion. So a very efficient beam delivery solution.
I saw you have a new product, the GC500X. Can you tell me a little bit about that?
Absolutely. So we're very proud of this machine, and we just got the award here at this conference for Innovation of the Year. So the GC500X is now the new record holder for the most powerful compact laser on the planet, and it still runs on a 110 outlet. It's smaller than the chairs we're sitting on. It's only 17.25 inches wide, and it will run on any power globally, but like in the US, a standard 120 outlet, but it'll also run on anything from 90 volt to 240 volt single phase, 50 or 60 hertz. So you can plug it in here or in Australia, Japan, Europe, doesn't matter. It'll run anywhere. And it is incredibly powerful, very tunable, very compact. You can put it in the back of a quad and go out to a remote location. You could use it on a helicopter, you could take it on ships, so they're very easy to move around. But it's a lot of power in a very compact package, and it's the result of our team at GC Lasers kind of always pushing the envelope and making better products for the past 11 years now.
Wonderful. And is there anything else you'd like to add?
So yes, very much so. I'm very happy to see how much traction laser cleaning is getting. A lot of people have misconceptions about lasers. Like, for example, they'll think it's Star Wars or burning things and cutting through things. And yes, there are lasers that cut things, like laser cutters. This is a very different type of technology. So one of the things we encourage at our booth, for example, is for people to touch the metal just right after we've cleaned it, and it's not hot. And we say our lasers are cooler because they literally do not make a significant temperature change on the surface. There are other lasers out there that will, so don't just think you can touch anything after a laser hit it, because sometimes they could be hot. Ours do not make a hot surface. But the educational side of it is very important. It's excellent that there's new standards coming up, guidelines with AMP, of course. I am happy to be very involved with AMP as well. We've been doing webinars and white papers and contributing in many different ways. So I encourage anyone who'd like to maybe hear me talk about it a little more, that they could watch the webinar we did in December. We have another one coming up in about a month or so. So at the end of the day, whatever laser you've seen, there's different machines. There's also different skill levels. Training is very important, and we're very heavy on training. But the key thing is, it's another tool in the toolbox. There's times when it's amazing. There's times when it's completely the wrong tool to use. And other times when, if you combine it with another tool, you get a result that was previously impossible or is done much faster. So it's definitely a tool worth having in the toolbox, though. And to have it properly, you have to learn about what it can do and what it cannot do.
Wonderful. And I'm Sammy Miles, Editor-in-Chief with AMP Media. Again, I'm here with Bartek Dajnowski with GC Laser Systems, and thank you for joining.